Alright guys, so we are back in my garage for another video, and surprise, we're headed up to Nostrum High Performance. We're going to go up there and tour the facility and meet the people that make all the parts that we're starting to enjoy. I'm really excited to work with a company like this that, one, is close enough where I can just drive there, and two, they work really closely with me on the technical details of how all this stuff works. They understand I have an engineering background and I really enjoy nerding out on that stuff. And so they invited me up to see exactly how they make the parts, how they do quality control, you know, and everything that makes sure that you get the best possible components possible. So we're gonna head up there. I'll take you guys along with me. We'll tour the facility and see what it looks like. So let's go ahead and do it.
Now, as always, for everybody that's new to the channel, I create these videos to help keep you updated on the latest developments in our community, as well as discuss technical topics so that we have a better understanding of how our engines work. So if you're interested in more videos like that, be sure to subscribe because there will be a lot more coming out in the future.
So this is our Telesis laser marker, and everything starts here.
Okay.
So everything gets born here. Okay. So there are programs for every SKU that have not only the part number, and every part number is unique to a unique serial number. So this is where it gets born. Okay. This data then gets sent to the database, and everything gets saved on a server.
Okay.
Then what Cherie is going to do is, after it gets laser marked, she's going to do her inspections, and she's also going to scan it. And when she scans it, it does two things for us. It checks that the 2D code works, because everything gets a 2D code, and it imports that data to the inspection sheet.
Okay.
And that inspection sheet is used pretty much all the way through the shop. So every lot work order has one Excel file which has the control plan, and then all the inspection sheets for all the different operations.
So you can trace it through.
Yeah, so you can see kind of like it has everything in there that has to be checked, and then she populates it, and then it automatically fills in green or red or yellow depending on where it is in the tolerance.
Got it.
So these are the new PRW gauntlet pumps, and so this is a batch that's getting started and getting born right now. Now, Cherie said she's waiting for paperwork, and that's because in our enterprise system we use work orders to move everything.
Sure.
The serial numbers all get married to a work order. So if, for example, you call me or Nick answers the phone and a customer says, hey, I think I'm having an issue, you know, can you guys help me? We can say, okay, what's your name? And we can go get his order, and then from the order we can see the exact serial numbers we shipped him. And then from those exact serial numbers we can go see the data for the injectors. So before we even hang up the phone with him, we can see everything about what he's got.
Okay.
That's
Thank
how
you.
they look when they're done, though.
Got it.
And then here, like here's the work order, right? So they're scanning the work order. We know what the work order number is. We know what step it is. We know what the lot size is. And then this is all being tracked through the system.
Got it.
And it goes all the way to the sales orders, like the shipments.
Gotcha.
Now we also laser mark injectors here. So like here is an S58 injector. And you can see that it has its 2D code. And this 2D code is what the team is going to use to trace it all the way through the shop.
Okay.
So they're going to scan this at different stations, and it's going to auto-populate the unique serial number and the part number, and it's going to connect its data to that.
Gotcha.
Here is a unique asset that we have for spray development. Okay? So how do we differentiate ourselves? Quality, design, and specifically in sprays. Every engine family has kind of a different spray pattern. We can look at some examples of that here. This is an LT4, and this is a different variant of the LT4. This is the 6mm, and this is the 7.5mm.
Gotcha.
So you can see that they're very different spray patterns. They're both V8s. Okay. And then what do we got here?
Yeah, so this is like the 3.5, the 4.35.
The 3.5 EcoBoost. You can see how different this is. And the orientation matters. So you have the arrangement of the spray, but you also have what we call the clocking, the rotation of the spray. And that's important for how the injector is installed in the vehicle.
Right, right.
So we're starting with as close to possible of an OEM core, and that gives us the error-proofing pin like on this S58, so that the repeatability of the installation of the injector is always the same. Because the rotation of the spray matters.
Right, right.
Okay?
Yeah.
What's this one?
Yeah, this is another example of the 2-3.
So this is, well, let's look at, these are two EcoBoost family, right? So this is a 3.5, this is a 2.3, and you can see, you know, the arrangement is different, but the clocking is totally different as well.
Right.
Now what we're measuring here in this patternation is Bruno is able to process this and get the mass distribution for every hole in the injector. That's what you're looking at here. And also, he can calculate the coordinates and geometry for every spray hole coming out of the injector. So we can map the spray, and we use it for development, we use it for setup, and we also do it for auditing during production.
Sure.
Okay? So again, sprays are critical from our point of view to the full range function of an engine, including the cold start and including transient response.
Sure.
So this is a very unique asset. We actually bought this asset from Delphi. So the SAE standard for patternation is actually written
Based on
this.
Okay.
And actually, a lot of the GM developed injectors pass through this machine too, because Delphi provided the injectors for GM. So
Wow.
And we do some contract work to continue testing, because that's the SAE standard.
So this is the one that can actually tell where it's spraying and how much is
Yes,
coming out of
exactly.
each.
Yeah.
Okay.
Exactly.
So yeah, so here it's like the cell. So each of these cells, they have like a transducer in it.
Okay.
So we position our injector, and we are firing the injector over time. And this is basically collecting our spray, and it's collecting. We set like a cutoff, so 80% of those cell volume is filled. It stops the test so it doesn't overspill and give us wrong data.
Sure, sure.
And as it collects on each of them, then it's able to reconstruct the spray that you see
And
over
make that,
here.
okay.
And then we can do that analysis as Frank mentioned. Okay, I can see the coordinate for each of the plume, how much mass it is. I can do I want to see the overall spray center of mass. Because when we are modifying our injectors, we want it to be behaving as close to the stock one. So we can see okay, or modified injector, how does that change on the center of mass or the cone angle of the spray, because you want it to perform well in vehicle.
Right.
This is at very low pressure just for demonstration, but gonna start it. We are doing at low pressure, so let me increase the pulse width, so it's gonna be, so you can see it splashing, you can see on the wetting the cells, and you can see on the screen over here, that's real time.
Oh, so it's filling up.
Yeah, and you can see we're not doing anything, and once it reaches 85%, it stops itself.
Got it.
So you can make sure that the data that you are getting is proper, and you just save the data and you can analyze it. Here I have all the data that it was shown on the piece of paper. So I can move over here and select, okay, this is the spray that we are adding it, how much is the angle, how much is the percentage mass, and depending on the type of injector you're working on it, I want to see as a single spray, but some injectors, they have a really oval spray pattern shape, so you can actually change it too, and I want to see in an ellipsis shape.
Sure.
So this just provides all the data that we need, and you could see the test ticks very quick, so we can do all the tests. We do the test for the setup, we can do the auditing, the development, so it's a very good asset to have.
Awesome.
It's a unique asset as well.
Yeah.
And it's really fundamental in how we develop and control quality of the injector. When we say spray patterns are important, it's not because we just read a paper, it's because we do it.
Right.
Yeah.
Awesome.
And all the data on the website, it's
made
on,
here. Yeah.
Yeah. Yeah, so on the website you see all the patternation for each of the SKUs. You also see arc flash. That's another asset that we made. That's high-speed imaging. So it's basically firing a camera, a high-intensity bulb,
In the injector,
And the
you're
injector,
timing
yeah.
it like properly. So basically this is a dark chamber. So you fire the injector, fire the light in the camera. So you pick like that exact time, you know, the image of that exact time. And you can like do multiple, like at different times. So you can see your spray like over time.
You stitch all of them together, you make a GIF. Those are on the website too.
Oh yeah, I've seen it. Like starts jumping
So
through.
you can see like your spray like from the tip to like going over.
Right, right.
So those two complement each other, right? Like this is a visual, that one is more like a data for like a specific cross section.
Right.
They work very well together.
So the injector gets born during production, and then it comes. There's different ways we modify things. You know, electric discharge machining is kind of the standard in the industry for micro orifices. And so, you know, we have our own EDM machine in house. It's a 5-axis machine with 3 wires on it, okay, and 1 head. So here we have 3 wires, diameters, 5-axis machine plus the access for the head. So what we're able to do here is we can do different size holes at compound angles, and each hole can have its own compound angle. You know, the academic material says counterbores are significant in spray breakup. The counterbore being a step. So when you have an orifice, you have a counterbore, and that counterbore helps the fuel shear as the plume exits. Okay? And so we tend to put counterbores on everything because that improves the spray quality. Again, always going back to the best possible vaporization and spray characteristics we can develop for that product. Right? So we can do that here because you don't have to unclamp it. Right? So this is a very powerful asset. However, everything still has to get digitally inspected. So again, serial numbers are coming through the shop. They're going through this machine. Every single injector gets digitally inspected. So what Cherie or Meech would do is they're going to lay this out under the camera, and they're going to take an image of it, 300 times magnification, and they're going to measure it, and then they're going to enter the data for every single serial number, okay? And then it's going to automatically tell them if they're okay, right? So when you have the setup, there's some targeting that has to be done. So we're able to do that with using this and the patternator. And then once the process gets released, they run production.
Got it.
They're still doing 100% inspection. Every piece of data by part number, serial number.
So you use this for development as well as, oh no.
Yes, development and production.
Right,
and
right.
that's important. So we're using the same assets for development and production.
Right.
Why? Because it makes it very quick to move to production. You know, everything is vetted by the time we finish a pilot build. So when we do a pilot build, you know, we had already done prototypes. A pilot build is usually a statistically relevant quantity. And the purpose of the pilot build is to vet all the manufacturing and the quality system. And then that gives us statistically relevant data for the production release.
Yeah.
Okay? And then similarly, we have our own high precision CNC machine. It has a glass scale and a piezo probe. So every single injector gets measured automatically. And the piezo probe is measuring it, and then it's outputting the data, and the data is saved per serial number. Okay? So we have different processes, we mix and match, we have some other ways of modifying injectors as well. And then everything goes through this machine here. This machine is a fully automated test machine. Every single serial number goes through this machine. So this will do an array of tests. There's about 700 data points per injector, per serial number. This will do an SAE break-in. So it's already done the break-in period as described by Society of Automotive Engineers. And then it'll go through leak tests. It'll do electrical tests like continuity, resistance, inductance. And then it does 10 dynamic steps that are vehicle relevant. So what do I mean by vehicle relevant? So like granted, the calibration team, when they're doing the baseline work, they are looking at what is the pulse width required for cold start, what does it look like at watt, and what are the residencies. So they'll generate a residency map when they're doing a drive cycle, and that's what's programmed here. The other interesting thing is these are tested to a simulated vehicle drive current.
Okay.
So we can prescribe the drive current in detail, in time steps and values, as it's recorded in the vehicle. So we're using a picoscope in vehicle to measure that, and then we're reproducing it here.
Got it.
That's why the data is so accurate for that application.
So like different drive cycles or like something along those lines?
Well, different ECUs
Okay.
and different, calibration
Okay.
changes the current and the time. And modern ECUs use multi-strategies. So it might have one drive current for low pressure, another drive current for medium, and then a very high drive current for high pressure.
Right, right.
And if you don't test the injector for those drive currents, the injector doesn't behave the way you think it should behave in vehicle.
Right.
Okay? And I'm going to get into the reason why that's important.
Sure, sure.
So in addition to all the dynamics, it's doing 3 statics, and then it's doing max pressure and max flow. And that's unique. So the reason we do that is because when you are developing and making an injector, the flow rate capability of the injector is indirectly proportional to the opening pressure that it can overcome.
Sure, sure.
So as you increase the internal flows, your ability to open against high pressure starts to drop. And that's when you run into situations where high RPM, high pressure, the injector fails to open, or it doesn't open completely. So then you could have a lean event, or you run out of injector much sooner than you think.
Right.
Because the injector isn't opening fully, so the ECU is going to start to increase the time, the pulse width, but it's going to run out of pulse width.
Sure, sure.
Because it has a pulse width window that it can only open. So what it's doing is it's running a pressure sweep all the way to 350 bar. So it's firing the injector, and the intensifier, and you can see that huge black intensifier back there, is cycling and increasing the pressure as it's opening. And then we draw actually a curve like this. Okay? And we can see where the flow starts to inflect and where it stops opening. And that becomes a quality specification for every single SKU.
Got it.
Right? Okay. And then it also does opening and closing time. So we have an accelerometer on the injector while it's being tested, and we are recording essentially the opening and closing vibration related to the time for every single injector, and that becomes a quality standard as well.
Sure.
So there are some quality standards that are pass-fail, and then there are batching criteria. Okay? And that's where having this accuracy in data really shines. So every test is repeated 3 times, and then this is taking an average of the 3. And if the range of the 3 is out of a range, it will fail the injector. Okay, so it's looking at the repeatability as well. Again, every single injector goes through here. It's about 17 to 18 minute cycle time every single injector. And all of that data is post-processed in Python, and we're starting to use AI also integrated with Python, and that becomes quality control and then batching.
So when you say batching, are you matching the numbers for like a set that you sell?
Absolutely.
Got it.
Batching is extremely tight. That's a function of the quality control, the testing accuracy, and the lot size. When you're able to make a lot of injectors, you can see how we're managing parts, right? We're moving them through the shop. They're being cared for, very well, as you would see in an OE. Right? We're able to make the sets very, very tight. And that allows us to now have what we started in 2020, 2021 with a 1-cal strategy. Okay, I got this set, now I got to use this data. But if I change the set, or somebody else buys the set, they have different data. We don't do that. Our quality control and our specs are so good that we have one data set for the entire SKU.
And everything will meet that.
Everything fits in that data. Okay, everything fits in that data. And another reason it's so tight is it allows us some room to drift over time. The injectors do drift over time. But when you're that tight, you can accept that drift.
Yeah.
Okay, and you don't see it in the fuel trims. The fuel trims are always very small, and you don't set any codes, so it becomes reasonable. And the reason we started down that path, well, two reasons. One, in some of the old products we made, they were very difficult to tune. Okay, we didn't have this type of assets. We didn't have this type of process. So those are all lessons learned when we first started the company back in 2016 and 2017. Right? And the second reason is because we actually have done CARB certifications, processes with CARB. And the conversation with them was, well, you know, we're a manufacturer, and they're like, well, you're a manufacturer, you don't need to do it with a cert. The tuner needs to do the cert. Okay, those are our customers. What do we have to do in order for them to be able to do that? Well, part of the CARB cert is the tune. The tune is locked to the product. That meant for us that every SKU we ship has to fit in that locked tune.
Oh, that makes sense. Yeah.
Okay?
Right.
Yeah. So that's another reason we did it.
Awesome.
Okay? But this is you know, critical.
Yeah.
Everything we do goes through here, and then everything gets processed. It's really strict quality control. This is fully automated. So they're scanning the 2D code on the part. They're putting it in. Every different SKU has a different recipe. It has a different setup. Yeah.
And guys, that was a little bit of a tour through Nostrum. We weren't able to see everything. They do have some kind of trade secrets and stuff inside the facility, but it was a really cool walkthrough to see exactly how the injectors are made, how they do their quality control to make sure you're getting the best product possible, even down to the batching, how they test all of the injectors and make sure that when you get a set, they all match, so they'll all flow similarly and be easier to tune. And then everything that they do to make sure your tuner is able to tune your car properly, because they have calibrators in house, they have a dyno that they use for tuning, they're able to test everything, even in their dyno room. I was really excited to hear about this. I had never heard of this before, but they use their dyno room as like a climate control chamber. So they have a really big fan in there that can actually suck all of the air out of the room. I think they said they effectively replace the air 6 times a minute with how much vacuum it's flowing through that dyno room. And because of the way that it's sealed off and soundproofed, they're able to cool it down to significantly low temperatures. So they said they've gotten it down as low as 40 to 50 F in the summer and as low as 20 F in the winter. And by doing that, they're able to basically do a cold start calibration and test, so they can make sure that the injectors can start up the car even when it's 20 degrees outside, even when it's winter. You know, they go through all of that testing as a part of their development to make sure that it's a really good product. So big shout out to Nostrum for allowing me to come in there and showing all of those details. I was really excited. It allowed me to nerd out a little bit, and as you can tell, the owner is a little bit of a geek himself. He can really get into the details and share everything about all of the products they make. And it's just cool to see somebody in the community and providing a product that's that engaged in the development. You know, for everybody that thinks it's just another drop ship part, or they just drill the holes bigger and send you whatever it makes, you know, this kind of demonstrates exactly what they're doing with their products. So more coming soon. I actually didn't just drive up here to see the facility. We also finished up my tuning. So we tuned the car on E85, got some dyno numbers, so stay tuned for that. That'll be coming up in the next video. But otherwise, I think that's it for today. So thank you guys for watching, and I hope this helps. And if you have any other questions or comments, leave them down below.